In this video, we're going to go through the process to import a 3D model into the software, show you how to orient and position that and set its height, before going over to the Toolpath tab in order to create roughing, finishing and a cutout toolpath to create the part you can see here. This is the longer edition of this tutorial where we go into detailed explanation of each stage. There is a shorter version where we show you the process without such a detailed description that gives you an idea of just how quick and easy this would be if you weren't following along. Let's start a new copy of the software. Let's begin by defining the work area that we're going to bring our 3D model into. This needs to be big enough to accommodate the model and a bit of space around it to allow us to cut the part out if we require that. I'm going to click on Create New File. I'm going to set up a job which is 10 inches by 10 inches, Z0 top of the block, material thickness 3/4 of an inch, and the XY 0 or datum position in the lower left hand corner. Check here our units are set to inches, which I want to work in for this job, and then we're going to come down to an area where we can define the quality of the 3D objects in the software. If we click on the down arrow, there's three settings: standard, high and very high. You can see there that the higher the setting, the better the quality, but the slower things like my calculation times might be as I calculate toolpaths or other jobs within the program. In this case, for this job, we can probably work with the standard setting here, so I'm going to choose that and hit the OK button. To import a 3D object, we're going to need to come down to the Modeling tab, click on that. I'm going to choose the icon here to import a component or 3D model. This is the icon that appears to have sort of an eagle coming out of a folder. We click on that, we can navigate to the project folder, and in this case I'm going to open what is one of the standard pieces of clip art that comes with the software, this magnolia flower, and this is in a V3M file format. Hit the open button and we'll see a grayscale of that appear in our 2D view. Now it can be advantageous to see both the 2D and the 3D view when we're working with imported 3D models. To do that, I can come up to the View drop down and click on the option here to tile Windows vertical. So now I can see the 2D view on the left and the 3D view on the right. Now we can only see the 3D model in our actual work area there, so only the part of the model that overlaps our white square work area is visible now in the 3D view. Notice I can rotate this around, look at it from different angles and see it in different locations to get a better view of it. Now the first thing I need to do is bring this into the center of my job. So with the grayscale selected there, I'm going to come to the Drawing tab and I'm going to click on the icon here to align selected objects and click Align to Material in the center of the job there and hit Close. At this stage there's a couple of different ways that we can adjust the size, position and orientation of our 3D object. The object's selected at the moment. I can see that because the grayscale is highlighted and it's red in the 3D view. Now if I click on it again, same way a selected vector would, it goes into transform mode and I see these drag handles available both the 2D and the 3D view. Now with these it's possible, if I click in the corner here, to click and drag to stretch that, and I can do the same in the 3D view here by clicking and dragging. So you can see no matter where I access these from, it's going to make the edits and update both the grayscale and the actual 3D object itself. I can click on these hard blue nodes in the corner in order to rotate this around if I want there, and so I've got all the normal dynamic manipulation of this the same way that I would have dynamic manipulation of a vector, the only difference being that because it's a 3D object I can access those dynamic handles both in the 2D and the 3D as we saw there. I can also be very precise about my manipulation as well. If I just click on the undo to go back through the different steps that we did there, so this is as it was when we first centered it. With the object selected, I can click on the icon here to set selected object size. I'm going to set the anchor in the center, make sure link XY is checked there, and we'll set the width of this to be 11 inches and hit apply. So you can see there I've more precisely defined the size of my part. In this case 11 would be too big for our job, so let's just enter a value of 9, hit apply again in order to resize that once more. As well as setting the size, we can use a number of the other vector editing functions, including things like rotate selected objects. So maybe I want to set the center point and just rotate that around 5 degrees. Hit close. In addition, I may want to mirror it. If I was creating a left and a right part, I might toolpath it in this orientation, then come into the mirror selected objects function, make sure create a mirrored copy is unchecked. I can leave flip about job center checked and say flip horizontal, and you can see that's just going to flip that over now, so that, as I say, if I was creating a left and a right, I could just toolpath those both independently in order to cut those two parts. Once the 2D orientation is correct, then the last thing we need to check before we can start calculating toolpaths on this is the height of the object in 3D, or the Z height if you want to think of it in another way. To do that, I come down to the Modeling tab, and with the object selected, I'm going to click on the icon here, the wrench, to go into the properties. Within here, I could change the name of the object. I can change its combine mode if we're bringing in multiple objects. In this case, we're not. I can change the height. So here we've got almost ½ an inch. I'm going to actually change this so it's a little bit deeper. I'm going to set it to 0.55 and hit space on the keyboard to update that. I'm not going to change any of the other parameters. I'm happy with those, so we can hit close. And at this stage, I'm ready to machine this, so we can go over to the Toolpaths tab. So we could go down to the Drawing tab and click on the icon, or the shortcut key is F12 on the keyboard, and you'll see that's minimized the Modeling tab on the left and open the Drawing tab on the right there. I'm just going to refit the views. We'll go up to View, Tile Windows Vertical again, so 2D view on the left, 3D view on the right here. Next, before we calculate a toolpath, we need to do our material setup check. And if you are planning to machine this, it's important that your material setup and all the toolpath parameters that you enter are appropriate for your particular machine, your tooling, and the material that you plan to cut this into. Let's go ahead and click on the Set button here. Z0 is going to be set on the top of the block, thickness of the material 0.75, and XY datum in the lower left. Now what's very important here is I check the position of my 3D object within the depth of the block. Now normally it's advantageous to have a bit of a gap between the object you're cutting and the top of the block, so that if there's any discrepancy in material flatness or how you set up the Z0, you make sure you avoid any flat spots. So here I could either use the slider to do that, or I can enter a specific value. In this case I'm going to enter a gap above the model of 0.05. That means I have 0.05, then the 0.5 at 5 of an inch of the model, and below that 0.015 inch of additional stock. Lastly, we check our rapid and home position are safe and appropriate for how we're holding the part down, and we can click on the OK button in order to accept that information. Now we're ready to calculate our 3D toolpaths. It's important to understand what these 3D toolpaths will machine. At the moment, our 3D object is selected, but if I just click to deselect that, it isn't relevant to what I'm going to cut whether something is selected or not. The only thing it's relative is whether the 3D object is visible in the 3D view. On the Modeling tab, we have the component tree where we build up a 3D object potentially made of multiple 3D entities. The result of that component tree is what we see here in the 3D view and is referred to as the composite model. In this case, we only have a single object, so that's what we can see. But that is the object we're going to cut. What we have selected is totally irrelevant. It is always just going to cut the entire part that it finds within the 3D view. Now there are two types of toolpath we're going to use on a 3D object. The roughing to hog out the majority of material with a larger tool, and the finishing which goes in with a smaller tool to get the detail and finer settings so that we'll end up with a nice smooth finished surface. 3D roughing icon is here, so we're going to click on that. I'm going to select a tool from the tool database, and I'm going to choose a 1/4 inch end mill for this. I'm just going to take the default settings here and hit OK, and then we're just going to hit edit, and I'm just going to change the pass depth to 0.2 of an inch, and that will dictate the number of levels of cut that I'm going to get with this particular toolpath. Let's go ahead and hit OK there. I want to machine the model boundary, so what that's going to do is look at the 3D objects that I have visible in the 3D view and automatically create a boundary around the edge of them. Next, I'm going to enter a boundary offset, and this needs to be a value that's large enough to allow my tool to come down the side of the part. By default, the software is only going to take the center of the tool to the edge of the boundary, so I need to go past that by at least the radius plus my machining allowance to make sure the tool will fit down the side. So we'll use a nice big value in this case, which is actually the diameter of the tool, so we'll leave that set to 0.25. Machining allowance is a virtual skin that will be added to the model to keep the roughing tool slightly away from the finished surface. That just stops the part potentially from chipping and also makes sure there's some material left when we come in with the finishing tool to cut this. We'll leave that set to a value of 0.03. We can either Z-level rough, which is going to cut in 2D slices on the part and leave kind of a stepped finish, or we can 3D raster, which is more like a kind of semi-finish that'll go back and forward over the part with the roughing tool. In this case, I'm going to Z-level rough, and I'm going to choose to raster X and profile last. So that means it's going to lace cut back and forward along the X-axis, and after it's hogged that area out on a 2D level, it will come back and profile around any of the 3D objects that it's found on that level. We have the option to ramp into the job if we want to reduce wear and tear on the tool. In this case, I'm not going to bother with that. I'm just going to change the name of my toolpath here. You can choose whatever is appropriate to your naming convention and hit the calculate button. And in the 3D view, we'll see the material block has been drawn and our toolpath has been also drawn there as well. In addition, as well as opening or drawing the toolpath in the 3D view, we can see the preview toolpath form has been opened on the right here as well. Now, as normal, we can observe the tool moves itself, so actually the path that the tool's going to follow on our machine, but it's normally much more useful to us to see that previewed so we can get a virtual representation of the finished part. I'm going to click and change my material setting to something more appropriate. Let's go with the maple there. I'm going to change it so there's no fill color for my toolpath. I'm just going to click material color and I'm going to uncheck animate because I just want to see the finished result of this and click preview selected toolpath. So I won't see the tool moving through the part there, but once that's finished we can see how this part's going to look. I can maximize the 3D view if I want, and I can see the steps that are going to be cut to hog out the material on this particular job with those settings. At that stage, if I think this is okay for my roughing, the next thing I can go and do is calculate my finishing toolpath. Now you'll notice here we're slightly cutting through the edge of the part in this case. If that was a problem, then what I want to do at this stage is come back into my 2D view, select the object, and I'm going to hit F9 on the keyboard in order to center it. I could also move that using the drawing tools as well. Now, if we select our toolpath and click on the icon here to edit it, I can just recalculate it by hitting the calculate button, reset the preview, and preview that again so we can see that roughing toolpath machined in the new position there. So I like that a little bit better. I'm not cutting through the edge of the part. So at this stage, I'm ready to go ahead and calculate my 3D finishing. So I'm going to close the preview toolpaths form there. We can stay in the 3D view, click on the icon to go for the 3D finish toolpath. As I say, this is typically going to be done with a smaller tool to get a lot more detail. So I'm going to hit select, and from the ball nose area I'm going to select a 1/8 diameter ball nose tool. I could adjust the parameters in the tool database if I want, or if I'm okay with that we can hit OK, and I'll just take the defaults in this case. I'm going to use the model boundary. Again, we can add a boundary vector offset. In this case, it just needs to be bigger than the radius of the tool. We can choose whether to offset following the shape of the part or raster over it. In this case, I'm going to raster at an angle of 0, which means that the main direction is going to be along the x-axis. Now I can change my tool name again to something that makes sense to me, and I can hit the calculate button and we'll see that finished toolpath there. So now we've got a much denser toolpath. If I zoom in, you can see the path the tool's going to follow cutting back and forward over the job. Let's just click to go back to the ISO view, And once more, with the Preview Toolpaths form open and that selected, I can click on the button to preview selected toolpaths. So now we can see what our finished part will look like. We can zoom in on it and check to make sure that we're happy with that finish and that's getting the kind of detail that we were looking for on this job. If it is, I could actually now output these toolpaths if I want and cut the part you can see here. But in this case, what I want to do is also add a toolpath that's going to cut the part out when we've done the roughing and the finishing. Let's close the Preview Toolpaths form. And now to do this cutout, I'm going to use a profile toolpath, which is a 2D toolpath and will require me to have a vector to follow. So I'm going to come back over to the 2D view here. Let's just hit F on the screen to fit that in there. And we'll come over to the drawing tab again. So I'm just going to pop this out by clicking on it there and pinning that in place and coming down and choosing the drawing option there. And in actual fact, in this case, because I want to create a 2D vector based on my 3D object, I will need to come down to the modeling tab. So didn't need to go onto the drawing tab there. Select the modeling tab again. Select your object either from the 2D view or the component tree list. And we'll click on the icon here to create a vector boundary from selected components. So if I had multiple components making up my composite model, I'll just select them all in order to create this vector boundary here. Now we're not going to see too much change, but if I just click to deselect that and click here, you can see now I've got a vector that surrounds the outside edge of my 3D part. Now I can hit F12 on the keyboard to go back over to just show the Toolpaths tab, and with that vector selected, I'm going to click on the icon here to create a profile toolpath. Start depth is going to be 0, cut depth is going to be all the way through my material, so I'm going to type Z equals in order to pull up the thickness of my block there. I'm going to hit select, I'm going to choose a 1/4 inch end mill in this case, hit OK, and I'm just going to hit edit in order to override the pass depth so we can cut through this in 3 passes, take the rest of the default settings. I want to machine outside that vector, and in this case I'm not going to add ramping or tabs. We'll imagine we have a way of holding this part down. So profile, calculate, and there we can see that toolpath. I can preview the selected toolpath and there we can see what the part will look like when we've cut that. Now we can see there's a little bit of material been left in some of the corners, and the only way we could clean that up further would be to use a smaller tool in order to machine around the object. So that's really just one of those nice things that you can see in the preview, and now it's up to you whether you make a choice to do that or not. In this case, I like the way this part looks, and so what I could do with the preview is double click on the waste material in order to delete it, and I could save a copy of that image and send that to my customer to show them, and they would see the exact part that's going to come off the machine, assuming that I do all my machine tools set up correctly. In this case, I'm not going to save an image, which is going to close that, and imagine we're at this stage ready to save the toolpath to output to the CNC. To do that, we would just select the first toolpath we want to save, click on the icon to save the toolpath, uncheck the option at the top here. There I should see the toolpath I want to save in the list, and now I can choose from the list of post processors that are available. I'm just going to choose the G-code option here, and that post processor needs to be appropriate for your machine tool to convert this into the right language that your CNC will understand. To save this, we'd just click on the button here, give the file an appropriate name and hit save, and that would be the file we could take across to our CNC in order to cut our roughing toolpath. I'm not going to save that in this case. We could save the finishing by selecting it and clicking save, and the profile in the same way as well. As well as saving the toolpaths, we may also want to save a safe copy of our file so that we can open it and make edits at a later date. I'm just going to close the Save Toolpaths form here, come up to File and Save As, and in the project folder we'll call this Import3D Toolpath and hit the Save button there, and so you can see the file as we've set it up here in the project folder. So there we've seen the process for importing a 3D object into the software, orienting and positioning that object, setting its height, and then coming over to the Toolpaths tab in order to do our material setup, 3D roughing to hog out the majority of the material, the 3D finishing cut to get down to the main surface of the part, and then finally creating a vector so that we could do a profile cutout. This is the longer version of this tutorial where we had more detailed explanations of each stage. There's also a shorter version available where we go through the same process and show you just how quick and easy it is without such in-depth explanation. Thanks for watching this example.